Welcome back to my channel. In this session, we are going to be deriving an expression for a Schrodinger time-independent wave equation. So first, we will be considering a particle wave. So we will be considering a electron as a particle wave. So where electron will be having a mass m, and along with that it will be having particle nature also as well as a wave nature also. So if I want to write a wavelength for this particular particle wave, which will be called as de Broglie's wavelength, you know that de Broglie's wavelength can be given by lambda is equal to h by p. Take it as equation number 1. So since it is a subatomic particle in the quantum mechanics, so any subatomic particles which are in the motion will be always represented in the form of equation called as a wave function. So the wave function for the particle wave is given by psi is equal to a into e to the power of I kx minus omega t. Take it as equation number 2. So what do you mean by a? A is a constant which represents the amplitude, and k is the wave number, and omega stands for angular frequency. So this equation can be splitted into two parts. How we can split? I kx into e to the power of minus I omega t, where one is x, which is position dependent part, and one more part is there, that is time dependent. What do you mean by position dependent? So if the equation consists of a x value, that is displacement, we call it as a position dependent, and if it is a time dependent, the time will be arriving in the formula, so that is called time dependent. Now what I will be doing, I will be taking a e to the power of I kx, means position dependent value as it is as a psi, and I will be replacing the equation psi is equal to psi of e to the power of minus I omega t. So take it as equation number 3. Now differentiate equation 3 with respect to x, means I will be differentiating with respect to position, since we have a two term, one is time dependent, another one is a position dependent. Now with respect to x I am differentiating, so I will be only differentiating the x term which has a psi, and time dependent will be acting like a constant. So d psi divided by dx is equal to e to the power of minus I omega t will be a constant because there is no term of x here, and d psi divided by dx. Now once again we will be differentiating equation with respect to x. Second time I will be differentiating, so the equation will become d square psi divided by dx square. Since e to the power of minus I omega t is a constant, so we will be taking as it is, and d square psi divided by dx square. Take it as equation number 4. Right? Now the same equation, now equation 3 will be differentiated with respect to time. So here what we have done, we have differentiated with respect to x. Now we will be differentiating with respect to time. Now e to the power of minus I omega t will be the variable, and psi will be not having any time term, so this will be acting like a constant. So differentiate d psi divided by dt is equal to, since the psi is a constant term now, so it will be taken as psi, and you know that e to the power of any function will be having a differentiation of a same value, but whatever the constant has been multiplied, so that should be considered. Here minus I omega will be multiplied along with the exponential term. So this is the differentiation. Once again, differentiate again with respect to time. So if you differentiate this term once again, the d square psi dt square is equal to, so since the psi is a constant now, take it as it is, and e to the power of minus I omega t will be there. Minus into minus it will become plus, right? And I will become I square, and omega will become omega square. Now what I will do, we know the value that I will be always given by square root of minus 1. So since there is a I square, so you know that the square and square root cancel, I square value can be written as minus 1. So what is the remaining term? Minus omega square. So I square is replaced as minus 1, and psi e to the power of minus I omega t into psi, take it as equation number 5. Now we have equation 4 and equation 5 which has been differentiated with respect to x and with respect to time. Now for traveling wave, means any particle which are in the motion. So since my particle wave is also a traveling wave, it should obey a condition. What is the condition? The condition for this one is d square psi divided by dx square is equal to 1 over velocity square into d square psi divided by dt square. Take it as equation number 6. Now we have both value also. D square psi x value is also there, and d square psi with respect to dt square is also there. Apply equation 5 and 4 in equation 6. So what will be the equation? So in the place of d square psi divided by dx square, I will be substituting it as a e minus I omega t d square psi divided by dx square is equal to 1 divided by velocity square. So in spite of d square psi divided by dt square, I will be replacing it as a minus omega square and e to the power of minus I omega t into psi. Just I will be replacing. Since in the both LHS and RHS side there is a e to the power of minus I omega t, so e to the power of minus I omega t get cancels, and the remaining term will be d square psi divided by dx square is equal to minus of omega square divided by v square into psi. Now we know the fundamental that angular frequency, since the electron which is moving in the circular motion, if I want to give an angular velocity for this one, you know that the total angle covered is 2 pi divided by time period. So that you know time period will be 1 over time period is given as frequency. So what I will do, I will be taking it as a equation number 7, and we know that angular frequency will be always given by 2 pi mu. Just I will be replacing, since the electron is in a circular motion, so angular frequency is given by 2 pi mu, and the velocity is given by mu into lambda, the fundamentals. So multiplication of wavelength along with the frequency will always give us a velocity for any wave. So I will be taking this too and applying the main equation. So what will be the equation? D square psi divided by dx square is equal to minus of, in the omega square 2 is there, 2 2s are 4 pi square and mu square divided by, in spite of v square we will be using mu square and lambda square and into psi. Now I will be cancelling mu square and mu square is cancelled, and I will be writing the remaining term as d square psi divided by dx square is equal to minus of 4 pi square into psi divided by lambda square. So this entire equation I will be writing in terms of 1 divided by lambda square. How to do? So whatever the numerator term is there, I will be shifting to the denominator and I will be rearranging the equation. How to rearrange the equation? Just observe. Here the value should be written in the form of 1 divided by lambda square. So since 1 divided by lambda square should be written, so I will be taking 4 pi square divided by 4 pi square into psi into the denominator side. So the value will become minus of 1 divided by 4 pi square into psi d square psi divided by dx square. So I will be rearranging this term as it is. Got it? This I will be taking it as a equation number 8. Now I will be taking the kinetic energy of this particle wave. So what is the kinetic energy of a particle wave? You know that kinetic energy can be written as p square divided by 2m, momentum square divided by 2m. But using equation 1, so what is the equation 1? You know that lambda is equal to h by p. So here I have a p value, I don't have other value. So I will rearrange this term as p is equal to h by lambda. Just I will be replacing in the kinetic energy equation as p will be replaced as h square divided by 2m lambda square. This equation will be replaced. So take it as equation number 9. And just see, so here there is a term called 1 divided by lambda square in the equation, so which we already found. Just we will be applying that equation here. So kinetic energy can be given by h square divided by 2m, keep it as it is, and in the place of 1 divided by lambda square you will be applying, in the place of 1 divided by lambda square you apply minus of 1 divided by 4 pi square into psi d square psi divided by dx square. Got it? Now I will be multiplying this one. Kinetic energy is given by h square, 4 2s are 8, mass pi square into psi d square psi divided by dx square. So this is the value of kinetic energy. Take it as equation number 10. Now for a particle, total energy is given by, so you know that whenever the energy is taken as total energy, it will be always a combination of kinetic energy plus potential energy. So for currently what I will be doing, I will be taking it as a kinetic energy and potential energy will be taken as V. So I will be shifting this one for the RHS side. The value will be energy minus potential energy will be equal to kinetic energy. Take it as equation number 11. Now apply equation 10 in equation 11. Just apply the kinetic energy value. What is the kinetic energy value? H square divided by 8m pi square into psi d square psi divided by dx square. This value I will be applying for the equation 11. So E minus V will be as it is, and kinetic energy is replaced as h square divided by 8m pi square into psi d square psi divided by dx square. Now what I will do, I will shift all denominators value for the numerator and numerator value for the denominator. Now what will be the equation? The equation will be 8m pi square into psi into e minus v divided by h square is equal to minus of d square psi divided by dx square. So as soon as this is arranged, so I will be shifting all terms to one side. So then the equation will become d square psi divided by dx square, minus will become plus, in plus 8m pi square divided by h square into e minus v into psi is equal to 0. So this equation represents Schrodinger time independent wave equation. You can observe there is no time term appearing in this equation and is for one dimension. So if you want to write this equation for the 3 dimensions, so the dimension will become d psi divided by dx square plus d square psi divided by dy square, d square psi divided by dz square plus 8m pi square divided by h square e minus v psi into x y z is equal to 0. So this equation will be representing the 3-dimension equation for the Schrodinger time independent wave equation. So for the exam point of view, this is most important derivation. Thank you.